My Shiny app contains exploratory data analysis and visualization and predictive modeling. In exploratory data tab, we have the different functions for exploring the data. Like the exploratory data analysis is nothing but is the process of making or analyzing data to summarize the main characteristics using the visualization methods. The main purpose is to understand the data, identify the patterns, if it is have any patterns or not, and to know if there is a missing values or anomalies, and to formulate the hypothesis. In this exploratory data analysis, we use R language. The R language contains some functions, out of which first one summary function. This summary function gives us the whole summary of the data set and the structure. It gives the structure of the data, like what all the variables or columns it has and the columns data type and few of the observations. To know the first rows of the dataset, we use the head function or head method. This gives the first, usually it gives the first six observations of the dataset. Same wise, the last rows we can obtain using the tail method. To know the descriptive statistics, we use the describe method of function. Missing values. In this data, I find no missing values, so there's no issue for it. It's loading. Rename. This rename function is used to rename the column names and arrange the particular column wise. In this case, I used year, like it is sorted like ascending order of the year from 1990s to so on. Subject to view the specific column, we use the subset. Like in this case, I used drag. Mutate. To create a new column, we use this mutate function. And this is all about the exploratory data analysis which I used in this app. And visualization. I plotted many visualization plottings. For example, bar plot. Bar plot is the univariate plotting. It involves only one variable and it gives us the median of the variable and the quarter ranges. It gives us for every data. As you can see, this median, quarter number one, quarter three, minimum, maximum. Scatter plot is a multivariable plot which involves the two column or data two data subdata, like on one on x-axis and another on y-axis. It gives us the comparison like that. It's a multivariable plot, and bar plot can be used as a variable and multivariable data plotting, where in this case I used multivariable where for the diet low in vegetables and the curve. A pie chart is a univariate variable. In this, for each country, it's showing some estimation of probability. Line plot. A line plot is a multivariable. Again, it is having one column in the x-axis and another column in the y-axis. And in the predictive modeling section, I have used classification and clustering models. In classification, I used many algorithms. In classifications involves many algorithms, but I used decision tree classification and Kleiner classifier. First, we see the decision tree classifier. In this, I can see the decision tree feature scaling, where the data is split into training set and testing set and feature scaling it, and we got to see the decision tree plot phase having each nodes. That nodes have the probability percentage, and we can see the nodes here. It's the output, and for this we have the accuracy values. This confusion matrix is a performance tool to estimate the performance of a classification model. Uh, in this we have accuracy values. With these accuracy values, we will know the performance of the classification, whether it's performed good or not. and it's having some sensitivity and specificity values. With these type of values, we find the ROC plot here. It uses the sensitivity and specificity values. Yeah, and in Canonical classifier we have the same, like Canon is also another classification algorithm. In this analysis, same, the data is split into training and testing data, and which is scaling it. We got the accuracy values. Here Canon plot for different key values. I plotted for the different key values. Like suppose, just a second. Yeah, here for each value in the k value, there is accuracy is dropping, and it's plotting is a graphical representation, and with the numerical representation it's in here. Accuracy values are here listed down for different k values. Now we compare the decision tree and Canon classification, and we get to see that for the k is equals to 1, for different values of k we see the different value of accuracy. It's ranging by comparing, we get to know that decision tree algorithm is an easy algorithm when compared to Canon because it's accurate. Decision tree is accurate than the Canon. Canon is used to find similar values for the data, but decision tree gives the accurate value. It's having some nodes and so it gives accurate data. So I feel this decision tree is better and accurate and easier one. And I plotted RC plot here. And another model building type is clustering. Clustering clustering is also a different technique. It's the main point of the clustering is it groups the similar kind of data points in one group. It is an important tool which makes it useful for the very important roles in the data analysis process. I used hierarchical clustering. In a hierarchical clustering, the similar data points are grouped together and the classification go on. Uh, yeah, it's a hierarchical clustering. Here is the hierarchical plot, which is a tree-like diagram, which involves the similar data points like in the tree diagram dendrogram type. Just a second, slowly. Hierarchical plot. Yeah, it's a hierarchical plot, and hierarchical plot analysis is having some single complete average values. It's loading. So for the disturbance, my laptop is somewhat slow. Yeah, it's having some average value, single and complete value. This is my Shiny app, which is having three sections: exploratory data and visualization, graphs, and modeling techniques. Thank you.